So let us taking one example. A, B, C, D, the relation. In this relation there are 4 attributes A, B, C, D, and the function dependency given A determines B, C determines D. Okay. Now we have to find out is the relation is in 2NF or not. So what is the condition for 2NF? The condition for 2NF is the table must be in 1NF. So if that type of question is given, then we are assuming that the table is in 1NF. Now we have to examine if there is any partial dependency exists or not. If any partial dependency exists in any of the this functional dependency, then we are saying that the table is not in 2NF if partial dependency exists, and if there is no partial dependency, that means the table is in 2NF. Okay. Now what is the condition for partial dependency? X determines A. This must be the left hand side must be candidate key. Proper subset of candidate key. Proper subset of candidate key, and the right hand side must be non-key attribute or non-prime attribute. Okay, so we have to find out the candidate key first, and then we will see how we can find out non-prime or non-key attribute. So we have to find out the candidate key. What will be the candidate key? We are saying that left hand side is not catching A and C. So A and C closer, we will check first. So A determines A, C determines C, A determines B, C determines D. Okay, so all the 4 attributes we can catch using AC closure. So AC is one of the candidate key. Is there any other candidate key? So is there any replacement of A and replacement of C? I think no. So AC is sufficient and the only candidate key for this relation. So AC is our candidate key, and we have to separate the prime attribute and the non-prime attribute. So what is prime attribute? The prime attribute are the attributes which are taking part in the formation of candidate key. Here A and C are the 2 attributes which are taking part in the formation of candidate key, because AC is our candidate key. And what is non-prime attribute? The attribute other than prime attribute are all non-prime attribute. So what is non-prime attribute here? C and D. Now we have to check is partial dependency exist in these 2 functional dependency. So partial dependency, left hand side will be the proper subset of candidate key and right side will be non-key and non-prime attribute. Now suppose there is a set ABC. What is the proper subset? So null will be a proper subset, A will be a proper subset, B will be a proper subset, C will be a proper subset. A, B will be a proper subset of this set. B, C will be a proper subset. A, C will be a proper subset. So any set other than the full set is a proper subset. Okay, it is clear. Now if AC is our candidate key, now what is the proper subset of candidate key? A, C. Okay. So our one of the functional dependency A determines B. So is left hand side is a proper subset? Yes, proper subset of candidate key, left hand side. And right hand side is a non-prime attribute. Sorry, here it is B. B and D is a non-prime attribute. AC is a prime attribute. Prime attribute are the attribute that is taking part in the formation of candidate key. And all the attribute other than prime attribute is non-prime attribute. So attribute other than prime attribute is B and D. So B and D is our non-prime attribute. So here A determines B. Here A is the proper subset of candidate key. Yes. And B is non-prime attribute. Yes. These two conditions, and in both conditions are satisfied. So here exists partial dependency. If partial dependency exists, then not in 2NF. Okay. Now second, so one functional dependency checking is enough. That one functional dependency is checking is enough. Now we second functional dependency, C determines D. Okay, so C is the proper subset of candidate key. Yes. And D is non-prime attribute. Okay, so there exists also partial dependency. So the table is not in 2NF.